comes for a specifically of nature of simply supported beam, where there are two different supports are there, one is roller, another is hinge support. In that case there are two reactions, vertical reactions is here only one reaction RAV. So when we will using sigma V is equal to 0, then RAV which is acting upward minus UVL minus UDL, there is no effect of this concentrated moment comes in the calculation of sigma V. So if we will take sigma V is equal to 0, RAV minus the effect of UVL half into 25 into 1 minus 10 into 1, that is the effect of UDL is equal to 0, and we will achieve RAV is equal to 22.5. This plus sign indicates our assumed direction of RAV is right one. Now let us take sigma MA is equal to 0 to find out the moment at support A. See the figure. Let's solve over here. The concentrated moment acting over here 20 kilonewton into meter. The UDL is acting. This is the load which is acting. This load is of 25 kilonewton per meter, 10 kilonewton per meter. This has been converted in terms of equivalent point load system, half into 25 into 1, here 10 into 1. This distance is of 2/3 into 1. This distance from here is of 1/2. So if we will take sigma moment at point A is equal to 0, now here reaction I assumed in this direction as a RAH, this is direction of RAV, and I assumed let the moment at A is of anti-clockwise. This is assumption. You can use the clockwise also. Any sign conventions can be used before finding out the final answer. This is the preliminary assumption. And if answers comes to be negative, we have to change the direction. So now by adopting this sign, so first minus MA. Why minus? Because this is of anti-clockwise nature, and as per our sign convention, clockwise is treated as positive. Next, this creates of the clockwise nature moment plus half into 25 into 1 into 2/3 into 1. This is the perpendicular distance. Next, 10 into 1 plus 10 into 1 bracket, the distance is 1 plus half. This moment is there, plus 20 is equal to 0. If we will solve this equation, we can achieve the value of MA is of 43.33 kilonewton into meter. Here this plus sign indicates that our assumed direction is right, that is MA is of anti-clockwise nature, is of the right one. Let us solve the next numerical. The given beam, the beam whose one end or both the end is projected beyond the support. Yes, exactly right. The given beam is of overhanging beam subjected to UVL between the two supports and point load at the free end. of overhanging beam. And our intention is to find out the support reaction. Read numbers indicated equivalent point load for UVL. No horizontal force is acting on the system. RAH comes to be 0. Question may arise, then in which case RAH comes? If any direct horizontal force or if any inclined force is given to us, in that case only the value of RAH comes. Now in this particular problem, RAH is 0 because there is no any other external load, horizontal nature is acting. If you take sigma V is equal to 0, RAV upward, so plus RAV minus half into 20 into 4 plus RB minus 60 is equal to 0, and we will achieve one equation, that is RAV plus RB is equal to 100 kilonewton. Means summation of two vertical reaction is equal to total downward load acting on that beam, that is of 100 kilonewton. Now let us use the third equilibrium equation, sigma MA is equal to 0. See this figure, sigma MA is equal to 0. RH as such it is 0, no effect over here for a moment, and RAV which is acting at a point where we are interested to take a moment, so it is also 0. The effect of RAH and RAV for a moment at A is 0. So the first load which is of UVL, so half into 20 into 4 multiply by 2/3 into 4 creates a clockwise moment, hence plus sign. See over here, half into 20 into 4 into 2/3 into 4 plus sign nature. Next, RB creates a moment at A which is of anti-clockwise nature. So RB into 4 creates anti-clockwise, RB into 4. This another load 60. This 60 creates certain moment over here, but which is of clockwise nature. So 60 into perpendicular distance, 4 plus 1, 5. So 60 into 5 with the plus sign, and there is no another load, hence is equal to 0. So we will obtain this equation, that is half into 20 into 4 into 2/3 4, 2/3 into 4 minus RB into 4 plus 60 into 5 is equal to 0. By solving this equation we found out RB as 101.67 kilonewton. Now if we will put the value of RB in this equation, we found out RAV is equal to minus of 1.67 kilonewton. Minus sign, interesting point. See the figure. Minus sign indicated that we have assumed RAV which is upward, which is wrong. Means we have to comment over here that our assumed direction of RAV is wrong. RAV which is acting downward, we have to comment like this. See over here, RAV that is of downward direction. Now alternatively we can also find out the RAV by taking moment at B is equal to 0. If you want to check it out the same way over here, let us check it out by taking the moment a moment of all the forces at B. Now first force, as I repeat once again, RAH itself is 0, no effect of RAH on B, but yes, RAV into 4 which is of creating clockwise moment, hence positive sign. So RAV into 4, that is the first moment because of first force RAV into 4. See the component. Next one, this UVL, half into 20 into 4. This is the equivalent point load. Create a moment over here. So I have to take a distance, this one. This creates a nature of anti-clockwise. So minus sign half into 20 into 4 into distance 1/3 into 4. Half into 20 into 4 into 1/3 into 4 with the negative sign. Moment at B, so RB into 0, it is 0, but this 60 creates certain moment which is of clockwise nature. So 60 into 1 plus 60 into 1 is equal to 0. So we achieve the RAV is as minus 1.67 and minus sign indicated that our assumed direction of upward of RAV is wrong. RAV, the actual direction of RAV is of downward directions. So if sign conventions comes to be negative, only we have to comment on that our assumed direction is wrong. Next problem. Given beam, the beam whose one end or both the end which is projected beyond the support. Here the beam on both the side projected beyond the support. Hence the given beam is of nature of overhanging beam. And our intention is to find out the support reaction at A and at B. Carefully visualized in this whole beam, not a horizontal force or not an inclined force is acting. So automatically if you will use sigma h is equal to 0, RAH comes to be 0. If we will take sigma V is equal to 0, in that case the load which is acting downward, which is equal to total load which is acting upward. So tan into 1.2 which is acting downward, so minus tan into 1.2. Tan into 1.2 with the negative sign, plus RAV minus 40 minus 20 into the distance, total distance on which thus 20 kilonewton is acting, that is 20 into 5 plus RB is equal to 0. So if we will see this equation, we obtain RAV plus RB is equal to 152 kilonewton by using the sigma V is equal to 0. Now let us take sigma MA is equal to 0 to find out the value of RB. See this figure. So now let us find out over here. The supports are over here, the UDL which is acting over here, and this is the acting of point load, and then from this point throughout UDL is acting. This length is of 1 meter, this length is of 1.2 meter, 1 meter, 1 meter and 4 meter. 40 kilonewton, this is of 20 kilonewton per meter, and this is of 10 kilonewton per meter. Now let us take the moment over here at A. Before taking the moment at A, let us convert this point load in terms of equivalent point load. This is tan into 1.2 acting at this distance 1.2 by 2. This is the equivalent point load, 20 into 5. This distance is of 5 by 2. Now let us take a moment at A is equal to 0. The first load 10 into 1.2, that is the load multiplied by 1.2 by 2, which is creating a moment at A, is of anticlockwise nature, and with our sign convention anticlockwise treated as negative. This another RAV into 0 because we are taking moment over at A. So effect of RAV on the moment is itself is 0. Now plus sign. Why plus sign? Because this creates clockwise moment. 40 into 1. This UDL, another is 20. Equivalent point load is 20 into 5. Perpendicular distance is 1 plus 1 plus 5 by 2 creates clockwise moment treated as positive. This is next is RB minus RB because it creates anticlockwise nature into 4 plus 1 5 plus 1 6 is equal to 0. So finally, by solving this equation, we will achieve the value of RB as 80.47 kilonewton. By putting the value of RB of 80.47 in this equation, we will achieve RAV is of 71.53 kilonewton. We can solve the same problem by taking the moment at B also. In that case, we will achieve RAV. So you can solve by yourself by taking the moment over here at B. In that case, see the figure, if we are taking the moment